Hello everyone, welcome back. Here is Ali Talabi, and this is the wrap-up session for module 12. So let's start our review session by looking at some major notes, and then we'll look at a few questions. So in this module, we talk about the portfolio management, and we'll learn that how to calculate the expected return and the variance for the portfolio. We learned that unlike the return, the risk of the portfolio is not the weighted average risk of individual assets. And we mentioned that this is the case because of the correlation. Because two assets are moving together, so they are related together. So we should include the correlation coefficient when we calculate the risk of the portfolio. And actually, this is a positive note. Why? Because when we have this correlation, it helps us to actually diversify our portfolio. The correlation helps us just to reduce the amount of risk. There are two major factors which actually impact on the risk of the portfolio. One is the correlation, and we mentioned the correlation might be a number between -1 and +1. And as we are adding assets with a more negative correlation, we can reduce the risk. The second factor is based on the weights of the assets you are adding to your portfolio. The weights also play a major role in the portfolio's risk. We mentioned that the standard deviation is relevant for the total risk of the investment or portfolio. However, if you are looking for systematic risk or the non-diversifiable part of the risk, we should focus on beta. Beta is a better indicator of the market risk. So in other words, we mentioned the market is same as, there are different terms we use. The market is same as the systematic or non-diversifiable risk. The firm specific risk is the same as the unique risk, non-systematic risk or diversifiable risk, because we can actually get rid of that unique risk. Now let's look at a few questions from this module. And the first question, we have three stocks and we have a portfolio of these three stocks. As you see here, we know the number of shares, we know the stock price. The goal here is to find the weight of the stock A in our portfolio. So here you need to find the total value of the portfolio or the total market value of the portfolio, and then find the weight of each stock by dividing the value of that stock in your portfolio. So since our focus here is on A, so let's just find the total weight of portfolio and the weight of A, and then based on that we will find the actual weight of A in this portfolio. So we have 500 shares. The stock price is $20, so it means actually the market value of a stock A is $10,000. 200 shares of stock B, $10 each, which means you have $2,000 worth of stock B. And finally, 300 shares, $40, so you have $12,000 worth of stock C. Now, what is your total value for the portfolio? 10 plus 2 plus 12, it should be $24,000. So this is the total market value of the portfolio. We are looking for the weight of asset A. So the value of the asset A or stock A is $10,000. The total value of the portfolio is $24,000. So if you divide 10,000 by 24,000, you should get almost 41.7%. So the weight of asset or stock A in your portfolio should be 41.7%, or in terms of decimal place, it should be 0.0417. So the correct answer should be A, based on this argument. Now let's look at the next question. So your goal here is to form a risk-free portfolio. And we mentioned two conditions should be fulfilled to have a risk-free portfolio. Again, we're talking about two stocks in this case. One is you need to have the negative correlation. So the correlation should be -1. The negative is not enough, it should be -1. And also you need to set the weights in a way that the ratio of the weights are the reverse form of ratio of standard deviations. For example, if you have assets A and B, WA over WB should be sigma B over sigma A. So by finding the weights in this order, you can form a risk-free portfolio. So let's see which one is providing these two conditions. The return of two stocks should be correlated negatively. Yes, negatively, but it's not good enough. Not only negatively, but also it should be -1. So the statement 1 is not fully correct. The covariance on the return of two stocks should be negative. Okay, so we can use also the covariance to find the correlation. The correlation is a standardized format of the covariance. Covariance is showing just the co-movement of two assets. Correlation is also showing the sign of this co-movement, and it's kind of more specific than the correlation. So, and it's actually a standardizing based on the standard deviation of two assets. Just as a reminder, if you want just to know, so the correlation between assets A and B is the covariance between assets A and B. And when I'm saying assets A and B, I mean the return of assets A and B, just to make it more clear. Divided by a standard deviation of A times a standard deviation of B. So we are always using correlation. It's a better indicator than the covariance because, as I mentioned, it is a standardized form of the covariance. So it is actually taking into account the role of a standard deviation of individual assets. So the correlation should be -1, and the covariance, the negative covariance, is not good enough for us. The ratio of the weights for the stocks should be same as the ratio of the standard deviations of the returns. And remember, we talk about the weights, we talk about the standard deviation. However, the ratio should be in the reverse format. So that's why the statement 3 is not correct. The correlation between the returns of two stocks should be -1. So this is the correct one, as we mentioned before. The ratio of the weights for the stock should be inverse of the ratio of the standard deviations of the return. So also this one is the correct one. So 4 and 5 are the correct one. So the answer here should be D, which is saying 4 and 5. So we should choose answer G. So now let's look at the last or the third question. Which one of the following statement is not correct? Be careful, you're looking for the incorrect statement. A portfolio variance is a weighted average of the variance of the individual securities which comprise the portfolio. So we learned that when it comes to portfolio, the variance is not similar to expected return. So you cannot just go with the weights of a standard deviation or the variance to calculate the portfolio's standard deviation or variance. Why? Because of the correlation. So we need to include the correlation in our argument. So A is not correct, which is our answer. So B, C, and D are correct. Let's look at those statements. B, a portfolio variance is dependent upon the portfolio asset allocation. Remember, asset allocation, it means the weight. How much you are investing on asset A, how much you're investing on asset B. That's the meaning of asset allocation. And for sure, the weights are very important in terms of the portfolio's risk and variance. So B is correct statement, so it's not our answer. A portfolio variance is affected by the correlation between the individual securities held in the portfolio. For sure, that's the correct statement. The variance also highly dependent on the correlation between two assets. And finally, D, the portfolio variance must be less than the highest variance of any of the securities held in the portfolio. So that's the whole logic of diversification, because you will have a portfolio which has lower variance, lower standard deviation than the standard deviation of the individual assets. So D is also the correct statement. So the only incorrect one, which is our answer here, it should be A. That's it for today. Thank you very much. Have a wonderful day. Talk to you soon with our module 13, which is regarding beta and capital asset pricing model. Till then, thank you very much. Have a wonderful day. Stay safe. Talk to you soon. Here is Ali Talabi.